Okay, so yesterday we did the product rule, and today we're going to do the product rule's best friend, the quotient rule. So, kind of showing yesterday, we can do some of these with rewriting as polynomials. So, we've practiced this one here, where we could rewrite this by splitting up the numerator, right? You can always split up the numerator. So 2x cubed over x squared minus 3x squared over x squared, or you could do plus negative, and then plus 2 over x squared. And the reason this works is in math, if you have the same denominator, you can add those fractions. So now we can cancel out the x squareds, and we get 2x minus 3, and then plus 2x to the negative second. We're going to bring that one up. So this would be f of x. And once we rewrite it in polynomial form, then we can take the derivative. So we get 2. The derivative of negative 3 goes away. Minus 4x to the negative third power, which will become 2 minus 4 over x cubed. And that's a perfect answer, but if we wanted to write it as one fraction, right, we could make this 2x cubed over x cubed minus 4 over x cubed. And so we'd get 2x cubed minus 4 over x cubed. And you'll see why I did that in a minute. So that would be our derivative. Now, just like how we talked yesterday about Leibniz publishing the product rule, well, Isaac Newton was the first one to publish the quotient rule. So we use his definition still today, same thing, and that's that if h of x equals f of x over g of x, then h prime of x equals, and this one's a little bit weird, but it's going to be g of x times f prime of x minus f of x times g prime of x, all divided by g of x all squared. And there's a really kind of just popular saying to memorize this. And so what we do is we call f of x, we call that our high. And we call g of x our low. And I know technically it would be h-i-g-h, but I'm lazy. And so we say it out loud. We say this is low, g of x is low. Right, same thing would really be low, but I'm lazy. So low times d high, right, the derivative of the top, minus high times d low, the derivative of the bottom, all divided by low squared. So that's something that I'll have you guys practice in class that we'll say a bunch of times, but low d high minus high d low all over low squared. And whenever I do quotient rule, I never memorize the whole g of x f thing. I just memorize low d high minus high d low all over low squared. So if you want to kind of write that out, just write out the words, right? Low d high minus high d low all over low squared. So that'd be, how we say it. And so kind of showing how this works, we'll do that same example. We should end up with our same answer. So f prime of x equals, so it's low, so I'm going to put all these in parentheses. So low is x squared, we leave it alone. D high means take the derivative of the top. So the derivative of the top is 6x squared minus 6x. Then minus, now it's high, so we're going to leave the top alone. 2x cubed minus 3x squared plus 2. D low would be take the derivative of the bottom, which is 2x. And all divided by x squared squared, right? The denominator squared. So now we can just basically distribute, and we get 6x to the fourth minus 6x cubed. Now we need to also distribute this negative sign. So minus, you want to be careful about this. Minus 4x to the fourth, then plus 6x cubed, and minus 4x, all divided by x to the fourth. And now let's look for our like terms. So anything with the fourth power, I'm going to underline once. Anything with the third power, I'm going to underline twice. And we'll go 3 times there. So let's cancel out. And that gives us 2x to the fourth minus 4x all over x to the fourth. Now we cannot cancel out the x to the fourths. I see a lot of students who are like, oh, let me just cancel that out. It does not work that way. You can only cancel out a term if it's everywhere. So I have the lowest I have is x to the first, so I can cancel out an x to the first everywhere, make that cubed, and make that cubed, and we end up with 2x cubed minus 4 over x cubed. And that is what we had in our first example if you look up here. Right, 2x cubed minus 4 over x cubed. So now, like I said before, same thing with product rule. With polynomials, if you can rewrite it as a polynomial, a lot of times you'll save some time on algebra. So this one, maybe it wasn't worth it to do it with the quotient rule, and it was just easier to do it the way we did up here, with our rewriting. But you can't always rewrite it. So, for example, this g of x equals 2x minus 1 over x plus 3. We can't rewrite it because we have, basically, as soon as you have more than one term in the denominator, you can't rewrite it anymore. And so we have to do the low d high minus high d low all over low squared. Now, this does ask for a tangent line equation. So we're going to put x1 is negative 2. For y1, we're going to plug that into the original. So g of negative 2 is equal to 2 times negative 2 minus 1 over negative 2 plus 3. That's negative 4 minus 1 is negative 5 over 1, so just negative 5. Okay, and then for m, that's where we plug it into the derivative. So before we can plug it into the derivative, let's use another color, we need to actually take the derivative. So g prime of x equals, we're going to do low, so leave the low alone, d high, derivative of 2x minus 1 is 2, minus high, d low, all over low squared. So this is it with x's. Now, you can simplify, but whenever we're doing tangent lines or plugging in, I just plug in right now. I don't worry about simplifying. It's easier to actually just plug in first. So this gives us negative 2 plus 3 times 2 minus 2 times negative 2 minus 1 all over negative 2 plus 3 squared. That's negative 2 plus 3 is 1. 1 times 2 is 2. Minus, okay, now this is going to be negative 4 minus 1, so minus negative 5, all over 1 squared, which gives us 7. Okay, and so then from there we just finish out writing it. So y minus negative 5 turns to plus 5 equals 7, x minus 2 turns to plus 2. So we're actually going to learn, as we do quotient rule, we're going to learn the rest of our trig. And the reason, we can learn these is because now that we know this quotient rule, we can rewrite these. So we're going to kind of prove why they work, but at the end of the day, we're just going to memorize them. So f of theta, right, could rewrite f of theta as, tangent of theta. We can rewrite tangent of theta as sine theta divided by cosine theta. And so that gives us f prime of theta equals low would be cosine theta. D high would be the derivative of sine theta would be cosine theta. Minus high would be sine of theta. Times d low would be negative sine of theta, right? The derivative of cosine is negative sine. All divided by cosine of theta squared. So this gives us cosine squared theta plus sine squared theta, because the negative and the negative, all divided by cosine squared theta. If you guys remember, this sine squared plus cosine squared theta is always just 1. So this gives us 1 over cosine squared theta, which becomes, when you have the 1 over cosine, that was secant. So this becomes secant squared theta. So there's our answer. Okay, for cotangent, it's really almost the same thing. Cotangent of theta is cosine theta divided by sine theta. So we will end up with f prime of theta equals low sine theta d high, cosine's derivative is negative sine theta, minus, now high, we're going to leave cosine theta alone. D low would be, derivative of sine theta would be cosine theta, all divided by sine squared of theta. Now in this case we get negative sine squared theta minus cosine squared theta all over sine squared theta. Again, I see students try to cancel those out. Don't do that. It doesn't work at all. But what will work is whenever you have a negative and you want to get rid of the negative, you can just factor out that negative. And the reason we want to do that is we know that sine squared theta plus cosine squared theta, that whole entire part, again, just becomes 1. Right? That was our Pythagorean identity, that it just becomes 1. So this is negative 1 over sine squared theta. If we remember, sine becomes cosecant. So this becomes negative cosecant squared theta. So secant theta, kind of doing this one. Secant theta we can write as 1 over cosine. And you can technically do the quotient rule with this. It's a little bit funky, but we can do it. So what happens is we're going to write this as f prime of theta equals low would be cosine theta. Now for d high, the derivative of 1 is 0. Then minus high is going to be 1. D low is going to be, the derivative of cosine is going to be negative sine of theta, all divided by cosine squared theta. And so this becomes 0 minus negative sine will turn into positive sine theta over cosine squared theta. And this one's a little bit weird, but to rewrite this, what we do is we kind of write this as sine theta divided by cosine theta times cosine theta, right? And it's because that whenever you have a sine over a cosine, that part always becomes tangent theta. So what we end up with is we end up with essentially tangent theta times 1 over cosine theta, and that 1 over cosine theta we can rewrite to secant theta. And we end up moving the secant in front just because it rolls off your tongue better. So we write as secant theta tangent theta. Obviously having it flip tangent theta secant theta would work also, but generally it's the secant is just put in front because it just sounds nicer. So there's that derivative, and then finally we have the same process where we could say that cosecant is 1 over sine theta. And so, this is not the derivative yet, this is rewriting it. So we don't put a prime there, we put a prime once we actually apply quotient rule. That's important, right? So in this step, we did not put a prime, we're just rewriting it. Same thing up here, and we didn't put a prime, we're just rewriting it. We didn't put a prime, we're just rewriting it. So now once we do quotient rule, that's when we put the prime. So low would be sine of theta, d high, same thing as before, derivative 1 is 0, minus high, d low, derivative sine is cosine, all divided by sine of theta squared. So now that's 0 minus cosine theta will become negative cosine theta over sine squared theta, and we're going to do that same thing we just did, where anytime we have sine over cosine, it's tangent, and anytime it's backwards, cosine over sine, that's cotangent. So that part becomes cotangent, so negative cotangent of theta times 1 over sine theta, and 1 over sine theta becomes secant theta. And just like before, we're going to put the secant theta in front, so negative cosecant theta, cotangent theta. Okay, so here's the deal. Just off on the side, I want you to just write kind of memorize. And we're going to memorize these. We're going to look for a few patterns. Okay, you're never, ever, ever going to have to do the work that I just showed. Okay, unless you don't memorize these. If you don't memorize these, then you're screwed. But otherwise, you just memorize them, and this whole doing the quotient rule, you're never going to have to do again in your life, unless on a homework I tell you specifically to do it. But on the AP test, never. Okay, so f of x, if we start off with sine of x, we should have this one memorized already. The derivative is cosine of x. When we start off with cosine of x, the derivative is negative sine of x. Now, when we start off with tangent of x, we just did that one up in the upper left. We got secant squared. And then we can do it again for cosecant, secant, and cotangent. So I like to, though, group these. So I like to just group sine and cosine are kind of friends. I like to group tangent and cotangent are kind of friends. So the derivative of cotangent is negative cosecant squared x. And then I group secant of x was secant x tangent x. And then cosecant of x, its derivative was negative cosecant x cotangent x. So I want you to pause for a second, you could even pause the video, but look for as many patterns as you can, right? What patterns do we see? Look at the C's, look at the, negative symbols, what patterns do we see? So I like to kind of think that, one pattern I like to notice is these two are kind of friends, like sine and cosine are friends, and their derivatives are opposite. The derivative of sine is cosine, and cosine is sine, right? Tangent is secant squared, and cotangent is cosecant squared. Obviously there's a negative, but it's kind of the derivatives are kind of the opposite one. And for secant we have, it's really bad color, we'll just leave it unhighlighted. We have secant tangent, and for cosecant we have cosecant cotangent. So that's one pattern we might see. Another big pattern is with the negatives. Okay, anytime our original function started off with a c, then the answer for the derivative of something that started with a c was negative. So anytime, derivative cosine is negative sine, derivative cotangent is negative cosecant, derivative cosecant is negative cosecant cotangent. If our function starts with a c, our derivative will be negative. And then the last one I like is, again with the c's. Now this one doesn't work for cosine, but it does work for cotangent. If you can't remember, between tangent and cotangent, which one was secant squared and which one was cosecant squared, the cotangent starts with cosecant. Same thing for secant. Secant goes secant times tangent. The derivative of cosecant goes another c cosecant and cotangent, so the c's kind of group up. So make flashcards, do a Quizlet, whatever you want to do, but get those memorized. Okay. Find the equation of the normal line and get these memorized like tonight, maybe tomorrow. We are gonna have a mad minute on this coming up, so we'll have that this week where they have to be memorized. So next one, find the equation of the normal line. Now when we have normal line, we want to remember that's the perpendicular slope. So x1 is going to be pi, our theta. y1 is going to be when we plug it into the original. So f of pi equals 3 pi divided by, now cosine of pi is over here. That's at negative 1 comma 0. So divided by negative 1. So we get negative 3 pi. And for m, we need to plug m into our derivative. So in order to do that, first we have to actually find the derivative, and we're going to have to do quotient rule. So f prime of theta, we always do that first before we plug it in, is low cosine of theta d high, derivative of the 3 theta is 3, minus high 3 theta, derivative of the low is negative sine theta, all divided by cosine theta squared. And now we're just going to plug in pi. Like I said, I always plug these in before simplifying if I know I'm going to plug in. So cosine of pi we said was negative 1. So this is negative 1 times 3 minus 3 pi. Now the sine of pi, even though it's negative, sine of pi is 0, right? So we can just put a 0 here, so this whole thing goes to 0. All divided by cosine of pi is -1 squared. So this becomes -3. And so that gets us to our overall equation, which is y minus negative turns to plus 3 pi equals -3 times x minus pi. Now, that would be the equation of the tangent line. But they did not ask me for the tangent line. They asked me for the normal line. So you may even want to just add that in there, plus 1/3. And so I'm kind of running out of room. In your notes, you can write them both down. But I'm just going to go ahead and switch this to our normal line. And our normal line will then switch between, instead of the -1/3, it'll be positive 1/3 for that slope. So y plus 3 pi equals 1/3 times x minus pi. That's our normal line. So, few for practice. If you want to pause the video, try these on your own, and then watch it afterwards, you can. Or if you want to just watch me do it and take notes with me, you can. So, the key is here just recognizing as soon as I see in my denominator that there's more than one kind of term, I know for sure I have to do quotient rule. Also, inside your denominator, if you have like a sine x, or anywhere really, if you have trig, you're going to always be doing quotient rule. So, low would be x plus 2. D high, this is why we need to put in parentheses, is 2x minus 2. Those are going to FOIL. It needs to have parentheses or you'll miss out. Okay, then minus high, x squared minus 2x. D low would just be 1. All divided by low squared. And from here, you're just FOILing and you're just combining like terms. So this is 2x squared minus 2x minus 4x minus 4 minus x squared plus 2x, right? The negative distributes all over. Now, a big key is always expand the top and leave the bottom factored. Okay, again, always expand out the numerator, but leave the denominator factored. So the denominator is already factored for us, we're going to leave it. Okay, next we're just going to combine our like terms. 2x squared, negative x squared, negative 2x, negative 4x, positive 2x, and negative 4. So we end up with 2x squared minus x squared is x squared, then minus 4x, and minus 4 all over x plus 2 squared. And then once you've combined like terms, now we're going to factor the numerator, right? So now that it's all in a polynomial, now we can factor it. And this ends up being x minus 2 squared over x plus 2 squared. Nothing cancels. It looked like at first maybe something was going to cancel out, but nothing actually ended up canceling out. Oh, you know what? I think I messed this up. This should have been, yeah, I did mess this up. Okay. Right here when I did FOIL, we had x squared, 2x squared. I did correctly, negative 2x. This should have been positive 4x. So I messed up that symbol. And minus 4. So it should have been a positive 4x. And so with a positive 4x, actually nothing does factor out. So, right, if you try to do like your whole x method thing, there are no numbers that multiply to negative 4 and add up to 4. So this is actually our final answer. So definitely be careful with your signs. It does happen. So you just want to double check them. Okay, so g prime of x. We have low, d high. Now, derivative of the tangent we just learned was secant squared. So we're just going to write secant squared x for that. Then minus high, tangent of x. D low is going to just be 1. All divided by x plus 2 squared. So again, we're going to expand out the numerator, and we're going to leave the denominator factored. So x times secant squared would be x secant squared x. Do not multiply the x, with the x inside of secant squared. Right? This is x times secant of x. This x is inside of secant. This x is being multiplied to the outside. They're totally different. They're not like terms. Okay? So x secant squared of x, then plus 2 secant squared of x, minus tangent of x, all over x plus 2 squared. And like we said, we're going to leave the x plus 2 squared. Nothing up here is factoring out, right? With trig, we're usually never going to get anything factoring, and that's our answer. Okay. Next one we're going to have doing with sine and cosine, and this one actually will be one of the cases where we can't actually get something to factor. So once in a while, if you have sine, cosine in the numerator and the denominator, sometimes you can work some things to cancel. So low, 1 minus cosine theta, d high times cosine theta, minus high sine theta, and then d low. The derivative of the 1 goes away. The derivative of negative cosine becomes positive sine, right? Because two negatives, right? Derivative of cosine is negative sine, but then the extra negative turned it positive. Over 1 minus cosine theta squared. Again, leave the denominator factored always. Okay, now we're going to FOIL. So we get cosine theta minus cosine squared theta, then minus sine squared theta, all over 1 minus cosine squared theta. And originally this is going to look like 1 minus cosine theta all squared. I need to make sure we have the squared at the end. Originally this looks like it's nothing, like that's our answer. But you really, really always want to watch out for the whole sine squared and cosine squared thing. Okay? And basically if they're both positive, it goes to 1. Technically, if they're both negative, it would go to -1. But, what you can kind of do is kind of say this is cosine of theta minus, we could factor out a 1 and make this cosine squared theta plus sine squared theta. Right, so you're just kind of factoring out a 1 just from that right side. Technically, you could factor out a 1 everywhere and change the sign of the cosine, but I'm just going to factor it out there. So this whole portion just turns into a 1. -1 times 1 is 1. All divided by 1 minus cosine theta squared. So this becomes cosine of theta minus 1 divided by 1 minus cosine of theta squared. And this is where it's a little bit tricky, okay? This is something we're not used to with canceling. These are not the same, they're flipped. But you can always flip, like if I wrote x minus 2, we can flip it to negative 2 minus x. Right, if I have 3 minus x, we can make this negative x minus 3. So we can do that here. Whenever you see that they're flipped in the wrong order, you can factor out a negative sign and make this 1 minus cosine of theta divided by 1 minus cosine theta squared. And now what will happen is that's going to cancel out. So on the numerator, we get -1 over 1 minus cosine of theta. So I want you guys to, maybe rewatch that, especially the algebra parts, like the simplifying parts, because that's something that we're not quite used to, especially that last part with the switching the signs with pulling out the negative, but it's something that we are going to be expected to do when we are simplifying these quotient rules. Okay, and the next one's going to have a little bit of a similar trick, and I do want to talk about one. Just yesterday we added in f of x equals square root of x, right? If you want to find some room down here somewhere, right? We had talked about f of x being square root of x. I also want us to memorize 1 over x. It's very common. The derivative of 1 over x is -1 over x squared. That's something you can memorize. And if you want to take this a step even further, I actually memorize what I like to call reverse power rule. So what happens is, if you notice, is instead of subtracting by 1, we add on by 1. So if I wanted to take this derivative another time, right, basically we'll call this the second derivative, but if I wanted to take the derivative of -1 over x squared, what happens is you multiply the numerator up, but you switch the sign. The reason you switch the sign is when it's in the denominator, it's a negative exponent. So it'll become +2, and then it'll be over x cubed. If I wanted to take that even a step further, right, what would be the derivative of this guy? Well, the third derivative, we'll call it, will be, we're going to multiply up, switch the sign, so -6 over x to the 4th, right? We're adding 1 in the denominator. So I call that the reverse power rule. So that's something you can memorize, or just memorize, 1 over x is negative 1 over x squared. So I'm no longer going to, take rewriting that to x to the negative first. I'm going to just memorize that, if I ever have f of x equals to 1 over x, I can apply that reverse power rule, right? Multiply up, and switch my sign, and add on. So that's what I'm going to be using from now on. So when we do this, f prime of x, low, right? Low would be x plus 5. D high. Now for the D high, we're going to use that. So there's already a negative here, so that's going to turn to positive 1 over x squared because of the double negative. Then minus 3 minus 1 over x times the derivative of low is 1, right? So minus high d low. Okay, now this is a little bit tricky, but when we have basically a fraction inside of a fraction, the best thing to do is to multiply by that denominator. So we want to multiply by that denominator. Now I'm going to expand it first because I think it's a little bit easier, but I'm going to just kind of write this as, right, x over x squared plus 5 over x squared minus 3 plus 1 over x all over x plus 5 squared. And so now what I'm going to do is I'm going to multiply every single term by x squared. So times x squared, times x squared, times x squared, and times x squared. And so what we're going to end up having happen is that, 1x will cancel out there, and then the full x squared terms will cancel out here. And so that gives us x plus 5 minus 3x squared plus x, all divided by x plus 5 squared. And we'll just kind of rewrite it, combine our like terms. So I underline them. And then we want to put, the negative 3x squared first, plus 2x plus 5. And I don't believe that there's anything that adds up to 15, multiplies to negative 15, and adds up to 2. 5. Yeah, 5 and... Okay. So we can factor this, right? So if I kind of just take this down here, right, this would be... Now, you want to factor out the negative sign first. It's going to help out a lot. So always factor out the negative sign to get rid of the negative with your x squared term. So we know that basically I could have 3x plus 5 and 3x minus, it would be 3x minus 5. We want the negative. And 3x plus 3, right? Negative 5 and positive 3 would make negative 2, but we need to divide out a 3 on that side. So, we're just checking it to see if something will cancel out. So we get negative 3x minus 5 times x plus 1 over x plus 5 squared. So that would be fully factoring it. Now, normally, even though this is technically the answer, if we fully factored it, normally on the AP exam, they're just going to leave it here. They're not going to refactor it. So that'll be the answer. If anything, they might just take out the negative and do something like that. But really this should normally be our answer. But I'm just showing us, hey, we can factor it if we need to. Okay, so this next one, I'm showing you on purpose. It's really tricky to simplify this one, and so I just want to show you guys something to always check before you do quotient rule. So I'm going to do it the really long, hard way first, and show you, hey, check this to make it way easier just in case when you're doing quotient rule. So if we had done this one out by hand, right, f prime of x equals, and they're giving us the answer, they're saying it has to simplify to that, which is nice. A lot of times on the AP exam, they'll do something like this, but it's a lot easier than what this one is. And it's more comforting because you know what answer you're trying to get to. So low, x squared minus 1, d high, 2x plus 3 minus high, x squared plus 3x plus 2. D low would be 2x, and divided by x squared minus 1 squared. And so we're going to FOIL out the top. X squared times 2x is x cubed, 2x cubed. X squared times 3 is plus 3x squared. Minus 2x minus 3, right? We FOILed out the top. And then minus, I'm going to distribute this part, but I'm going to leave it in parentheses. So minus 2x cubed minus 6x squared, or sorry, plus 6x squared, and plus 4x. All divided by x squared minus 1 squared. Now you can go ahead and just switch your signs. So I'm going to just say, let's distribute this negative and turn that to negative, negative, and negative. Right, and you could have done that all at the same time if you had wanted to. And so now, anything with cubed in it, I'm going to underline, oops, I was underlining it once, or what I'm thinking. So anything with a cubed, I underline once. Anything with a squared, I'll underline twice. X I'll do 3 times, and then the number will do 4 times. So this ends up giving us the 2x cubes cancel out. 3x squared minus 6x squared is negative 3x squared. Negative 2x, negative 4x gives negative 6x minus 3. All divided by x squared minus 1 squared. Then we're going to factor out a negative sign with the 3. Always factor out a negative sign if your biggest term has one. That becomes x squared plus 2x plus 1 divided by x squared minus 1 squared. And this is where it gets funky. This is where it gets weird. And I'm going to show you, how to prevent that from happening. So this is going to become x plus 1 and x plus 1. Right, if you do the tree. Right, like two numbers that multiply to 1 and add up to 2 are 1 and 1. All divided by x squared minus 1 squared. And what you'll notice that's kind of keeping this from canceling out is the squared, right? That x squared inside, right? And, it's positive instead of negative. But even if I'd written this as like x plus 1 squared over x squared minus 1, right? First of all, it's positive, but second of all, the x squared inside is preventing it. So this is like the one time in like basically 99% of the time you never expand the bottom. But in this case, we're going to, just because we want to kind of refactor it. And that's because technically the denominator is not actually fully factored. Or sorry, it is, but we can rewrite it. So we can write this as x plus 1 and x minus 1, right? That's what x squared minus 1 is. Or like x squared minus 1 can turn into x plus 1 and x minus 1. Now, it was squared, so each of these guys are going to be squared. Right, or you could just write it out twice. Another x plus 1 and another x minus 1. Because it was squared. So what happens is now we can cancel out the x plus 1 parts. So we can say, hey, let's get rid of the x plus 1, the x plus 1. And that gives us negative 3 over x minus 1 times itself will be x minus 1 squared. Okay, very, very weird, very tricky to get to that answer. But what you always want to check first when you're doing these is actually, can I just factor it now? What if we factored it now before we did quotient rule? So in the very beginning, just like how you rewrite polynomials, what if we factored it? Well, this could become x plus 2 and x plus 1, all divided by x plus 1 and x minus 1. So that just becomes x plus 2 over x minus 1. And now if we were going to go ahead and apply our quotient rule using that, f prime of x equals, low would be x minus 1, d high would just be 1, minus high would be x plus 2, d low would just be 1, all divided by x minus 1 squared. And you'll notice if I change my signs, make that positive and then make those both negatives. Right, the x's will cancel out, and -1 and -2 turn to -3 over x minus 1 squared. So this was very, very easy, right? I just did basically that entire problem just right there instead of taking up all that room and really hard thought process, right? So the key is, if you can ever factor, always factor first before doing, factor or cancel or whatever you can do first before doing quotient rule. Okay, so that's a very, very big thing. So I kind of showed it both ways. I guess I had this room, so if you ran out of room, what I had highlighted, I guess you could have put in here, but I just kind of forgot about that. So what's our lesson? Our lesson is factor or rewrite first. So that's our big kind of key takeaway there. So now we're going to look at graphs, kind of like what we had yesterday. So the first one we're going to call P of x is going to be equal to f of x over g of x. And then we'll also define r of x as sine of x over f of x. So as we do these, p prime of 5. So in order to do p prime of 5 first, we have to get p prime of x. So p prime of x is going to be low. So low is g of x, d high, f prime of x. This is actually just the rule, minus high, f of x, d low, g prime of x. So again, just the rule. All divided by g of x squared. And then again, you can technically skip this step, but I like to plug in 5. It just makes my life easier when I'm going to, kind of plug everything in. But if you want to skip this step, you'll still get full credit. Basically, you would just plug them in as you went. So g of 5 is the y value. So at 5, what is our y value at 5? And it may even be helpful, honestly, off on the side, to kind of just write g of 5 equals 5, and to write g prime of 5 equals, now this is part of a line, so we're just going to look at the slope, up 1 over 1, up 1 over 1, up 1 over 1, so the slope is 1. And we can do the same thing over here, right? G at 5, that y value is at negative 3.5. And the way I know it's negative 3.5 is just look at the slope. The slope is, basically down 1 over 2. Down 1 over 2. So I know that, because the slope is negative 1/2, we know that those points are always at exactly a half. So negative 3.5 would be negative 7/2 as a fraction. So now we can go ahead and just basically substitute those in. So for g of 5, we're going to get 5 times f prime is negative 1/2. Then minus f of 5, we're going to get negative 7/2 times g prime of 5, we're going to get 1. All divided by g of 5 was 5 squared. And what I'm going to do is I'm going to just multiply everything by 2. So if I do this guy times 2, we'll cancel out. Then this side by 2, we'll cancel out. And then the denominator by 2. Basically, we're multiplying where that separates. So we're multiplying every term, and that's our separating term. So this ends up giving us negative 5, right, plus 7, all divided by 2 times 25 is 50. So that's 2 over 50, or 1 over 25. Okay, our next one, find r prime of 0. So before we can do r prime of 0, we need to do r prime of x. Now in this case, our low is f of x and our high is sine of x. So low would be f of x times sine of x's derivative would be cosine of x. And again, it's really good practice to put these in parentheses. Then minus high sine of x times d low f prime of x, all divided by f of x squared. And so I'm going to just kind of show plugging it in. I'm not going to rewrite the 0 every single time this time. But I do like at least kind of marking it. So for f of x, right, f of 0 would be at -5. And we don't know what f prime is, but I'm going to just show you, don't just freak out and stop. So we know that basically f of 0 is -5. But f prime of 0, we have no way of knowing that because it's not a line. In these other ones, we could do the slope was -1/2 because it was a line. We do the slope was 1 because it's a line. But I'm going to tell you a little secret in calculus. A lot of times they'll do this to freak students out, but it's going to be multiplying by 0. And so just keep going with it. And usually this term, we don't know it, but it's going to get multiplied by 0 to go away. So let's see if that happens here. So for f of 0, we said that was -5. Then times cosine of 0, right? On our all students take calculus chart, kind of 1, 0. So this is times 1. Then minus, sure enough, sine of 0 is 0 times f prime of 0. So it didn't matter what f prime of 0 is because the whole thing is going to go to 0. All divided by f of 0 is -5 squared. So this gives us -5 over 25, or -1/5. So there's our answer with that one. Now we're going to do the tangent lines for each of these. So the tangent line for this guy, x1 is 5. y1 is not going to be anything we plugged in already. It's going to be p of 5. So p of 5 is going to be f of 5 divided by g of 5. Right? It's the original. F of 5 we got was, these should have been f's. F of 5 we got was -7/2 divided by g of 5 was 5. So you can do times 2 times 2, and you get -7/10. Okay. So that's our y1. You could put -0.7 also if you were using decimals. And m is our slope, which we already did. We got was -1/25. Positive 1/25. I don't know where I saw negative. So positive 1/25. So this gives us y plus 7/10 equals 1/25, then x minus 5. Okay. And then same thing for the tangent line for r of x at 0. x1 is 0. For y1, we're going to plug this in. So r of 0 would be sine of 0 divided by f of 0. Now, f of 0 was -5, but it doesn't matter because 0 divided by anything is 0. And for our slope we did up above was -1/5. So our equation is y minus 0 equals -1/5 times x minus 0. And you can box this. On an AP exam, they might clean it up and just write y equals -1/5 x. But same thing. Okay, and then finally, just like we did last time, we're going to do these with a chart. So with the chart, same way we read it yesterday, this is basically saying f of 4 equals 1. This is like saying g of 4 equals 7. This is like saying f prime of 4 equals 8, and this is like saying g prime of 4 equals -2. So just making sure we're comfortable reading the chart. Same thing that we did yesterday. Whenever we estimate a derivative, this is just review from last chapter, right? G prime of 2.5, that's our y2 minus y1 thing. Now we're going to use 2 and 3 because that's what 2.5 would be in between. And so we're going to say this is similar to having g of 3 minus g of 2, y2 minus y1, over 3 minus 2, x2 minus x1. Okay, g of 3 is going to be -3. G of 2 is going to be -1 divided by 1. This gives us -2 over 1, or just -2. So that's our approximation. Next, if p of x equals g of x divided by f of x, what would be p prime of 4? And what does this say about the graph of p of x at x equals 4. So first let's apply quotient rule, and this is just going to be the rule. We can just kind of copy the rule, except that f and g are flipped. You want to be careful about that. So low in this case is f of x, so it is flipped from what our rule says, times g prime of x minus high g of x times f prime of x, all divided by f of x squared. So now when we plug in 4, right, f of 4 is, we're in our top row, f of 4 is 1, times g prime of 4 would be negative 2, minus g of 4 would be 7, times f prime of 4 would be 8. All divided by f of 4 would be 1 squared. So this gives us negative 2 minus 56 all over 1. So we get p prime of 4 is equal to negative 58. Then it asked us, what does this tell us about the graph? What do we know about the graph? Well, what does the derivative tell us about the graph? It tells us increasing and decreasing, right? So therefore, the graph of p is decreasing. Now we don't know the whole interval, we just know it's decreasing at x equals 4 because p prime of 4 was less than 0. So we know it's decreasing there because it's less than 0. Okay. What is our next one? Now this one's definitely kind of our bonus question of the day. So if you want to really, really impress yourself, impress me, pause the video and try to do this one. And, you know, even without a hint, but if you want a hint, would be, what do we see? Well, we see 2x squared is being multiplied by f of x over g of x. So there's kind of a multiplication there, so that would be product rule. And then inside the parentheses, we have quotient rule, and we have to do PEMDAS. So if you want to pause it, try it on your own, you can. Otherwise, you know, we'll do this one, and it's actually not as bad as it looks. So what we actually do is we start off with the outside. So the outside is product rule. So we actually do product rule first, okay? And that's weird. You'll get the hang of these, but you don't, you know, when we're doing the derivative, what ends up happening is it's kind of like, you know, say we have q of x equals 2x squared times f of x over g of x. Kind of what's happening is you're applying the derivative, just like you would square both sides. And so you're applying the derivative here. It doesn't go inside. It goes to everything. So you actually do the product rule first, and then you go inside. So it's a little bit interesting. But what we do is we do the product rule first. So the derivative first, 2x squared, would be 4x. And we leave f of x over g of x alone. And then plus, now we're going to leave 2x squared alone. And now we're going to do the derivative of the second. So low, g of x, d high, f prime of x, minus high, f of x, d low, g prime of x, all over low squared. And now we're going to just start plugging in at 2. So 4 times 2 is 8. And then f of 2, right? F of 2 is 2 divided by g of 2 is negative 1. So 2 over negative 1. And plus 2 times, now we're plugging in 2. 2 squared is 4. 4 times 2 again is 8. Times, now this one, g of 2, right? So g of 2 is negative 1. Times f prime of 2 is 9. Minus f of 2 is 2 times g prime is negative 1. All divided by negative 1 squared. And so this gives us 8 times negative 2 is negative 16. Plus 8 times, now that's negative 9. Minus 2 is negative 11. Over 1. No, I messed that up. Negative 9 plus 2, right? This is minus, we got to be careful about that. Basically, negative 2 times negative 1, that's negative 9 plus 2 is negative 7. So that's negative 16 minus 56, and we get negative 72. So we'd say q prime of 2 equals negative 72. Okay, and then our last one's a lot easier. So the last one you could definitely try on your own. The only hard part about this one is it is the equation. So they want the equation of the tangent line. So x1 is going to be 3. For y1, we need to plug this in. So we need to do v of 3. So 3 times 3 is 9, divided by g of 3. Divided by g of 3 is negative 3. Right, we were plugging that into the original. So we did essentially 3 times x divided by g of 3. And so that gave us 9 over negative 3, which will become negative 3. So our y1 is negative 3. And then for m, this is where we need to do the quotient rule. So we would need to do v prime of x first. So I'm going to do it down here where I have a little bit more room. V prime of x would be low, g of x, d high times 3, minus high, 3x, times d low, g prime of x, all divided by g of x squared. And now we're going to plug in at 3. Right, so at 3, g of 3, we said was negative 3, times 3, minus, now 3x would be 3 times 3, so minus 9. And g prime of x is 6. G prime of 3 is 6. So minus 9 times 6 over, and then g of x again was our, I believe it was negative 3. Yeah, negative 3 squared. So this gives us negative 9 minus 54 divided by 9, which is negative 63 over 9, which is negative 7. So this gives us y plus 3 equals negative 7 times x minus 3. And I know it's a lot of work, but that's our equation. Now, it did say find the equation of the tangent line. Just be careful, if it says find the slope of the tangent line or find, the normal line, just be careful with exactly what it's asking. So homework again, pretty similar to yesterday's homework as well. We'll do this in class tomorrow, but we'll do the quotient rule with rewriting and with the actual quotient rule. Then we'll practice some quotient rule ones, and then we'll do one with a chart. And 11 and 12 then are with the trig. So I didn't put any graphs here. We'll do a day where we do some graphs. But then again, just kind of second last reminder is memorize all of those trig derivatives that we learned, the sine, cosine, tangent, and then the secant, cosecant, and cotangent, because we will be having a little bit of a pop quiz on them this week.